And for the roundtable, I did start a Google Doc. It's just a suggestion if you are more comfortable writing down your questions there, or it would be more free flow. But yeah, that's all I had.
Yeah.
Elena
Thank you so much. Any questions?
I have a question.
Go for it, Elena. No?
Oh.
Go for it.
Okay. So are there any plans to modify read-only S3, this ROS3 VFD, to be read-write?
To be writable?
Writable, yep.
No, I don't think there is. John, do you know of any effort? Yeah, I don't think it's feasible. Yeah, there's no plans.
Have you had requests to do this?
No, I don't, not that I'm aware of.
Okay, thank you.
Mm-hmm.
My question was, you mentioned a security vulnerability in H5D read chunk. As someone who's using that quite a lot, can you elaborate on that a bit?
Yeah, it's because you didn't pass, the old API didn't pass in a buffer size that you're reading into. Somebody can exploit that feature. So what we're introducing in the updated API is you will pass in the size of that buffer that it will read into.
I see. Thank you.
Thank you. Any more questions?
Yeah, so I'm glad you talked about Doxygen and documentation. I guess one thing I was alluding to earlier when Gerd was speaking was kind of the stability of the URLs of the documentation. Often with downstream packages and wrappers around the C library, I want to cross-reference into your documentation, and that's moved around a few times in the past few years. Do you have any thoughts on how you could stabilize those URLs?
Yeah, we are planning to we hopefully have stabilized it now. So if you see issues with it not being stabilized, you should probably talk to us, because I think we've pretty much eliminated, for example, we don't provide hard-coded links now, for example, to 1.14.6, right? It's now just latest something, something. So we tried to eliminate a lot of that hard-coded version type stuff in the documentation itself. But other than that, all the links should be pretty stable now. They all should point to the support website internally, even in Doxygen. But if it doesn't, then we'd like to know.
Well, I think something that I've worked, I think with Gerd with in the past was the availability of the Doxygen tag file, which allows us to, say, go from a function name to a Doxygen hash, I guess, to locate the page for a specific function. And I'm not sure if that's currently available. Is that something you could make accessible?
Yes, I believe we can. And we're also trying to improve our search engine in the Doxygen. I think it's still a work in progress. Somebody can correct me, but I think that still needs some work and to be able to search the Doxygen docs.
That is
better than they are now.
It needs work.
Something else I noticed when I was researching virtual data sets and whatnot, I referred to in my talk, was that some of those are only partially Doxygened. Yeah, they're still PDFs or whatnot, and I was having a little bit hard time finding that this time around. So I'm wondering if there's some extra set of documentation files or specifications that could be brought into the mainline documentation.
Yeah, I think we are in the process of trying to convert all those older documents in the PDF especially into Doxygen, but it just, a lot of them we haven't had time to do it. But yeah, that would be a nice addition.
Yeah, thanks.
Especially with some of the features that we developed, the RSC kind of is the documentation, which isn't probably the best method, because the RFC, things change when you actually implement it, and that just didn't get updated in RFC. So if you're going just by the RFCs, it's probably not the best source of the documentation, especially for prototype features.
All right. So I also have a question. It's regarding the ROS3 interface. I had a brief look at it, and I see it now, kind of why you chose to go to AWS implementation. But I also noticed that so previously the API was quite serial, so there was no room for concurrency. But now the AWS kind of allows for that, and so therefore you kind of ported the usage of that interface into the rest of the code, or you still kind of just did a quick swap that's currently working, and you plan on improving further after.
I think, who's online?
I
Is it
think
one of our
I
developers?
saw Jordan online
Is
earlier.
Jordan online?
Yeah, I'm
Yes.
online, Scott. So the effort was really just a quick swap currently, but as you noted, since the library has a very async IO oriented interface, I think it gives us a lot of opportunities to improve that in the future. I don't know that there are any specific plans currently, but it is a nice improvement.
Yeah, thanks. I was basically asking this because on Wednesday I'll talk a bit about the NetCDF usage for ZAR, and I think they did some copy paste basically of this ROS3 interface, which I was kind of looking into, and yeah, that's just to give some context. Thanks.
Thank you. Okay, if there are any more questions, I have a short organizational question. Who would be interested in a facility tour on Wednesday? I just need a rough estimation. Okay, roughly 1,000 people. Okay, thank you so much. And with that, we probably can proceed to the roundtable. Yes.
Does anybody want to start off with a roundtable discussion topic? Can we pull up the people online, or I can't? Just fitting the, yeah, people. Did you want to?
Yeah. So someone during today mentioned like the overlap between ZAR specification and HDF5. I'm totally new to HDF5, but I have some background on ZAR, and I just wanted to understand if someone could actually confirm this, and if that's the case, what would be the best place to kind of integrate at least reading ZAR in HDF5 if it could be done with some plugin layer, or which one?
Well, yeah, I spoke about that earlier, and I think Elena and I had a conversation. I think the plugin level would be this the VOL. What's that stand for? Volume Object Layer or something. But it's basically an abstraction of the HDF5 API, and then you could basically get it to read ZAR that way.
Virtual object layer.
Virtual object layer. Yeah.
Right, I was going to say that as well. It's kind of interesting that I'm going to talk tomorrow, and one of the ideas I've had is to be able to read ZAR from the H5 PyD, which give you like a HDF API in Python at least. But if you need a C API, you'd be out of luck. And another thing we've discussed is kind of like the going the other way of making additions
to the ZAR schema to support HDF constructs. So ZAR is very HDF-like, but there are aspects of HDF that you can't really replicate in the current ZAR format, like heavy multi-linking, for example. So we kind of pose this idea of, could we, make additions to ZAR optional extensions that would provide a kind of round trip compatibility between HDF5 and ZAR? Thanks.
Yeah, I think both would be very possible, and I think ZAR is just getting to a place where it would be amenable to such extensions. There's starting to be a more formal optional extension process now. One thing I'm a little worried about that is I am aware of some incompatibilities among different compression codecs or whatnot. So LZ4 has been a particular point of great pain, just because the particular implementation for HDF5 differs from other implementations for ZAR or other formats, for example. And so that would be one point to try to sort out is, how do we identify the HDF5 implementation of LZ4 as distinct from, say, the ZAR implementation of LZ4 and other things. I guess since we're still talking about ZAR, something I've kind of contemplated and the difference between HDF5 and ZAR community is that ZAR has been really actively encouraging multiple implementations of the specification in a way as to kind of as a check almost, right, to make sure that the specification is actually detailed enough that other people could implement it, but also to cross-check the implementations. I'm starting to wonder if this is something that we should also do in the HDF community, is to actually encourage more implementations of HDF5.
I can maybe chime in. This is Gerhard. Well, there are at least two other implementations. One is the pure HDF implementation in C#, and the other one would be the JHDF5. And absolutely, we encourage that. And I would add, I've actually reached out. I mean, we don't have anything to announce yet. For me, one of the first steps would be to get out of this dismal. I mean, it served its purpose, but to just have an HTML file or a Word document for the file format specification is I'd say not fit for purpose. And nowadays, if you look at languages / description languages such as GNU Poke, this is the type of environment or framework in which we should maintain the HDF5 file format specification, for example, because then at the same time you would have a reference implementation of a serializer, deserializer, where implementers, prospective implementers sort of could draw some inspiration from and have a good starting point.
Yeah, absolutely. I think, one of the strengths of HDF5 is that there's a really solid C implementation. And I think that would actually be a great advantage for other implementations, is that we can cross-reference to the C implementation. I think, perhaps one disadvantage for that, though, is that the HDF5 specification is rather large now. There's a lot of things that are, that are maybe there for backwards compatibility, but don't really mash up to modern HDF5. And I'm wondering if we could streamline the specification for possible other implementers, just to make it easier, or perhaps create sub-specifications that people could achieve different compatibility levels, so that one doesn't necessarily have to implement everything all at once.
Yeah, I completely agree. I would point out, though, that in a way, if you look at the HDF5 library, most of the code in the library, I would say 90% plus of the code, has nothing to do with the file format specification. The actual serialization, deserialization, that's a small portion of the metadata cache, let's say. Implementing use cases, that's what 90% of the HDF5 library is about. If you want to implement something like Swimmer or VDS or something, has nothing to do with the file format specification, but of course, and sort of it creates a little bit of what I would call a distorted optic, because yes, the C library implements a lot of use cases, but one should not, and I'm not saying that that's what you are doing, but you cannot infer from that, oh, that must have something to do with the file format specification. I think it does not, or only to a very small degree. But I completely agree. For robustness, longevity, and many other reasons, we want more implementations and make it much, much easier for people to get started and simplify wherever possible.
Yeah, and there is no need for new implementations to look at all the versions of header messages, but they have to be in the file format for backward compatibility, because we are committed of that any version of HDF5 library should be able to understand old versions of the files created by older versions, right? And new implementation may kind of relax this requirement, but HDF5 in general cannot, because data is archived in many different, versions, and every released version of HDF5 has to read data created during those 25 years.
Right, absolutely. Although I have many cases where, I'm writing in some language, whether it be Java or Rust or SIG these days, and all I want to do is be able to write a compatible file that the C library can read, and not necessarily that the C library from 10 years ago can read. And so yeah, I could see there's different kind of interest there, but it would be good to, just to focus on kind of the stable version of HDF5 and what can the C library do today? What's the most optimal way to do it? I think it's ironic in the many ways is that I think the specification is very powerful and it's very well detailed. But on the other hand, some people see the size of the specification as also being detractor, that it seems complicated. And I think if we could work on making it seem less complicated, more simple, I think you would find that other people would find more use cases for the file format.
Right.
So going back to Quincy's talk about GPUs, are people planning to start using the GPUs with HDF5? I know I was recently at a talk or a conference where they actually had mentioned that they want to start compressing the data right off of the sensors. So, and to do that, they wanted to use the compression and then use a GPU in line to do that compression and then store that in HDF5. Is there plans for people to use currently GPUs?
Yeah, we're doing that already. So either GPUs or FPGAs, perhaps even FPGAs embedded into, let's say, a camera. There's a company called, I think, Dot Photon, which makes a product called Jet Raw that actually does that. And I think they have several camera manufacturers on board for the technology. But yeah, in many of our cases now, since the data sizes have become so large that we've needed to do online compression in order to manage data sizes. But yeah, I think this is maybe where we've seen increased interest in kind of the direct chunking APIs, just because this enables that. And so there's a product called Amaris Writer from Amaris is a visualization software, but they developed a kind of parallel compression library. I don't think it's GPU based, but it is kind of a thread parallel. And that's often the bottleneck for some of our IO of just compressing and decompressing chunks. And so something like what Quincy mentioned would be great.
Like this was mentioned now, how like GPUs and computing and FPGAs, like there were two presentations in the last European HUG about usage of HDF5 and on FPGAs and GPUs. Yeah, well, both using the direct chunk interface. Yeah, and we were like, what we were missing is that I think that we don't know how to read the chunk directly into the GPU memory. Yeah, when we would have it, then we can deal with that. Like, so that something like that would help us. Yeah, which is much less demanding than what was shown today. Yeah, but also what was shown today is much more generic. Yeah.
Yeah, this is in part why kind of I had worked on that chunk iteration interface, which basically, just gives you kind of the offset in a file for the standard vol. And so basically, right, if you know the location of the chunks inside the file, then you can use whatever file APIs, whether it be NVIDIA's direct IO interfaces or whatever they call it, to directly load into the GPU. But I think that's a very different kind of approach to HDF5. As opposed to, we're going to build a C library that's going to do all the pipeline processing for you versus kind of a lower level API that identifies where are the data structures. But that's one solution. I don't know what the best approach to that is.
But I believe Quincy did mention, or maybe I missed it, there is a direct GPU VFD where you can read data from HDF5 file directly to GPU. So I don't know and this is for CUDA, and TG folks will correct me, but it's working, and maybe it's worth trying and see how it works.
Yeah, but it only works in serial, I believe. It doesn't work like if you have an MPI program, it won't work.
But I believe here we're discussing sequential case and parallelization application. Since it's direct chunk read, application will be responsible to using multiple threads to decompress data.
Yeah.
The only thing, of course, is that it's not multi-threaded, so you still will be waiting for when next chunk is read, right?
Well, I think Francesc talked about this approach earlier, with the BLOS2 approach, which is, again, I think very similar to what I just discussed. If we, you don't have to worry about if the C library is implementing threading, if basically where the chunks are and you can read that independently of the C library into a thread-based decompression or compression library. And so that's how we got around this issue.
Mm-hmm.
Yeah, exactly. So this is Francesc. Yeah, we are using the direct chunking approach with a lot of success. And also, in order to read also different chunks in parallel, we are also implementing asynchronous I/O so that you can read different chunks in parallel at the same time, right? So these chunks are stored in memory, waiting for when one chunk is decompressed, the other chunk is decompressed immediately after, okay? And then while there is a thread, this is reading again when more data is needed. So we are achieving like a double parallelism in the sense that we are reading in parallel different chunks, and also different threads can decompress the same chunk. This is working great, actually.
I see. We will be working, I don't know if we have, we're working, I will be talking tomorrow about enabling multi-threading in HDF5 library. And one of our tasks, if we have still time left, is to make a VFD layer multi-threaded. And then we'll have the whole, I will show you tomorrow how multi-threads can go, and then that problem will be solved with a multi-threaded wall connector. But it's still work in progress. Then there is no need for knowing where chunks are located. HDF5 wall connector will do it for you. So we are going that direction already. And right now we're reading directly from getting information from HDF5 library for location of the chunks and using thread pool to read chunks and seeing some improvements. You're correct, but it would be nice if it is inside HDF5 library. And we're very close to it, so but the development takes time.
Okay, so going back to the GPU case, my understanding is one of the problems in GPUs is the compression and the compression mechanism. That is, I mean, GPUs are not designed, right, for doing compression because there is a lot of conditionals, and GPUs are not efficient in this case. So, and I think Quincy mentioned that they are going to add new hardware specifically for compressing and decompressing in GPUs, or I misunderstood that information? Anyone has some information?
That's how
okay.
I understood it.
Because,
unfortunately, Quincy isn't here at the moment. But you know, I spoke about charting and ZAR, and I think Francesca has something very similar in terms of dual layer partitioning. But I do note that part of that specification came from NVIDIA and their NV Comp team.
Exactly.
Basically, right, if we have larger chunks that contain smaller compressible units within them, then we could basically load this larger chunk into the GPU and do parallel decompression across many smaller chunks, and then bring that back, right? That's a little bit more GPU friendly. And so I think that's my current perspective on that. The other thing, that I've noted is that there's been a lot more work on video decompression and compression on the GPU. And that's something that I think people at my institute are now actively exploring. There's a little bit different for us because many of these things are lossy compression formats, but I think we're realizing that we're going to have to accept that at some point if we're going to scale.
Very quiet. See if there's any questions on that.
Hi. I feel a little guilty throwing in such a simple question in the midst of such deep stuff and lossless compression, but my most powerful piece of metadata is camera images, just snapshots from a camera, that it would be just so lovely to dump into the HDF5 and just to be able to view in HDF view, have just JPEGs be a first-class data format that you could put in a file for documentation. Is that completely silly? Has everyone asked this already? I'm a fairly new user and I haven't read all the forums. Is everyone already asking for this? Is it possible? Is it sensible?
I guess
I can answer from historical perspective. So there was discussion to add to HDF5 MIME types. So for example, when you're writing JPEG image, it will be the attribute that it's JPEG, and then tools like HDFU can easily display because HDFU has this option to display. The JPEG image. Another way will be to use wall connectors to display it. So ideas were floating around, but it was never implemented in this direct way. But it's definitely possible and very useful.
It's such simple metadata. Everything else I have to work on, and images are just images, and they give me so much.
It does support JPEG compression. I believe it's JPEG 2000, and there is lossy compression too, I think. Look at the filters that registered with HDF5. But the problem is that you have to provide some metadata information to indicate that it's JPEG. But in terms of real, if JPEG, and TG folks will correct me, if it comes as dynamically loaded filter, probably not, because if it was like this, then library will automatically find it and will display the image. So it's really not much work to do. One can take that JPEG compression and create as a dynamically loaded filter, which is existing mechanism in HDF5, and then your image will be read transparently with all HDF5 tools, including HDFU.
I guess another aspect is the HDF5 image specification.
Right.
So that's a set of attributes that would tell applications like the viewer how to display that image. So if you would have combined like a filter to decompress a JPEG and a way to create those attributes, I think you'd be all set. But anyway, I want to mention that tomorrow we're having a viewer roundtable. This would be a good topic for that as well.
Mm-hmm. I would throw in one more, since the gentleman, I believe, said that this JPEG image is actually a piece of metadata. So let's say a barcode or a thumbnail or something like that. The easiest way to store this would be, and I'm talking about storing first, displaying second, just create a so-called opaque type, and then you can use each opaque type has a tag, and that could be the MIME type, for example. And then it would be just a matter of, in HDF view, to look at tags such as this, where the MIME type is just the tag name, and then it's just a matter of displaying it. So I wouldn't, because otherwise, if my assumption is you want to treat this as an attribute, and unfortunately, attributes are not second-class citizens, but they are decorators rather than, we don't support partial I/O on them.
I think I discovered that array lengths are limited to 1024 elements, possibly in attributes. I think I bumped up against some limit.
No, it's okay. In version one, in one of the 1.8 version, we actually removed that size limitation. Yeah, there, in the very early versions, there was like a 64 kilobyte limitation. However, in the 1.8 family of releases and subsequent releases, attributes can be arbitrarily large. However, as I was just alluding to, they are still treated atomically in the sense that you cannot read part of an attribute. It's either all or nothing. And that's where they are different from data sets. But if your JPEG images are a few megabytes, for example, not a big deal. You can stick them into attributes and decorate them with the MIME type. And until, let's say, HDF View offers native support to pick up on that, you can always have your own.
Yes, it was obvious. I could always just stick binary in there and decode it myself, but I wanted a way that someone with no tools could just pick up
Mhm.
HDF View and see the pictures that were in there.
Yeah.
Lowest friction as ever, trying to find
Yes.
something
Yes.
easy.
Let's come back to that tomorrow. I'll give it some thought. Mhm.
Actually, you can just quick trick. You can write JPEG as with direct chunk IO as one chunk for the data set, and specify that you will specify the compression, and then library should read it transparently. Just treat the image as one chunk and use direct chunk API to write it.
To add to my difficulties in using HDF5, I'm actually working from LabVIEW and using the old live HDF5 library, which has become abandonware, sadly. So now currently looking at switching HDF5 implementation in LabVIEW to the other LabVIEW HDF5. I only just recently discovered that there is an HDF5 Group plugin for LabVIEW, but only for reading HDF5. It would, for LabVIEW, maybe we're a tiny proportion of the population as LabVIEW users. We will soon be extinct because AI can't write LabVIEW. So everyone will move to languages that can be written by AI. But while we still exist, it would be very nice to have official HDF5 group support for LabVIEW. I would imagine a lot of people that want to write or who should be writing HDF5 probably may well be taking their data with LabVIEW. It is laboratory data and still a lot of us are using it. Knowing we had a officially supported route into HDF5 would be a great relief.
Yeah, this is a very common problem that that I have at my institute as well. So I've taken several different approaches depending on who's implementing the LabVIEW, because we have at my institute are all kind of optical engineers, who are maybe more amateur programmers, and then we also have some outsourced development of LabVIEW code as well.
Which
so
is
one
even
approach
there's no professional programmers.
Well, it's usually that once it gets to professional programmers, we're usually trying to clean up after, and trying to figure out how to make this sustainable. But kind of one approach I've taken is this binary template approach, which I mentioned in my talk.
Oh yes, yeah.
So in this case,
Is the husk of a file, put your content in here. Yeah,
exactly. And so that's the other kind of application I have for locating chunks in a file, is that if I know where the chunks are supposed to be or the data set's supposed to be, then I can tell my LabVIEW programmers, open the file, seek to this offset, and write your data there. And that's something they can do pretty easily. And it's maybe less trouble than trying to import the C library, and then or using one of those pre-contained kind of plugins. I mean, the thing that I've always struggled with that is that they don't always implement all the API, and they don't have the one call that I need. Then it's a bit of trouble trying to figure out which HDF5 library we're using today and how to put the right plugins in the right place. So
I believe I'm using a new enough library that should allow long attributes, but I have a feeling that maybe the LabVIEW implementation of the library is sanity checking the length of the attribute before it gets to the library. And that's why I'm finding I'm limited to 1,024 elements in an array. So yeah, other people's code is always a problem. Interesting. Thank you.
Jordan has a question or raise hand.
Oh, not a question. I just wanted to bring up for Tom real quick that HDFU does have support for importing various image types and other file types directly into an HDF5 file, but I think it's kind of limited in that it basically imports one image to one file, which might be a little bit annoying, but there is a quick, low friction way to at least, throw it in an HDF5 file so you can share it with people. But as other people have said, you don't really get any of the metadata niceness around it.
No, the definite thing was to put the pictures in with the data they belonged with, so it could all travel in a neat package. But yeah, I did manage to open a JPEG and then realize, it just sits there on its own and can't be in with everything else. So the decoders are there. So like Elena said, we're close to being able to do it. It just needs to be told, hey, that's a JPEG, show it. But we can talk about that tomorrow in the viewer session.
Yeah, I did link that there's a JPEG filter that is registered. I think is implemented by Mark Rivers at East Chicago Argonne National Lab.
Right.
But the other thought there's also this user block that you could maybe take advantage of. I think I talked about taking advantage of that to use TIFF in a combined TIFF HDF5 file, and that's another strategy you could use.
Yeah, I did see that uncompressed images were not a problem if I didn't mind putting it, but then my pictures ended up being bigger than my data, I think, when I DJPEG'd them.
Well, and for attributes, we can not use all these tricks. So for attribute, you really have to store JPEG image as a data set and then have like attribute that is referenced to that data set.
Yeah, that's not a problem. It doesn't actually have to be an attribute.
Right.
I tend to have one measurement per file and all its attributes in that file. So if that meant extra data sets in the file that were the images that belonged with it, that would be fine. I don't get hyperdimensional with the files just because we have to move them across the network and we're not doing carefully chunked reads and writes that everyone's talking about. If I want to open the file, it all ends up getting sucked across the network. So it kind of makes sense to choose a file scope that isn't too awful to copy across. Interesting.
Maybe related to this question is I'm also quite new to HDF5 and I found it quite difficult to get started with it. So there are so many AP calls and possibilities to put your data here or put it in an attribute or put it in a group or attach some attribute to something, and you don't get much information on how to get started and how to do maybe easy things. Yeah. So when you look at the documentation, you see how to chunk your data, how you create hyperslabs and so on and so on. And this very soon gets quite complicated that I started asking myself, is this overkill for my easy data?
There is H5 book by Andrew Collette. He has very good introduction, and there is also tutorials on HDF5 on HDF Group website that really walks you through the Python API. So maybe they can not be easily found.
Yes, but I'm not using Python. I'm using C#.
Oh, it really does matter because it just gives you idea how you organize your data and what you need to do, and then you use appropriate interface. But this is the only, to my knowledge, resource that really talks to this aspect of HDF5, how to start, how to organize your data for different use cases.
Because maybe it also has to do something with this, how is it called, NDT file format, where he said that you have to think about how to structure your data. Yeah, because as soon as I create my own structure, nobody else will use that structure. Maybe. Yeah, it's only my software which uses this exact structure, and if I pass it to someone else, he says, this is complete bullshit. Why didn't you do it like I did? And so I find it hard to find guidance on how to structure your data. Is there some knowledge base where you could
What kind of data?
find information about this?
What kind of data are you looking to store? What is it from?
We are doing microscopy with spectral data and making images out of spectra and storing all the data and then post-processing it to images and false color images.
That sounds to me like in let's say photon and neutron sciences, we have on top of HDF5 a convention how to store data in HDF5, and that we call Nexus, the most common one. And that says us we should structure our data. Like Nexus. Yeah. That it's a question if the Nexus exists for your type of data, because this means that we do tens or hundreds of different type of experiments, and for each of them we almost need like a convention. But one can also look in the other techniques. You can find another spectroscopy, for example, is similar to yours, and this will give you guidelines. Yeah. There are people who you can discuss with them Nexus.
Okay, thanks.
I did have a question for you, probably Elena. With the Onion VFD, what was the decision to have to keep that Onion file separate from the HDF5 file?
Because it was a quick and easy implementation. It was much easier to implement because it was still a prototype, but design and specification, I believe, discusses all three versions. And also it was not clear if we can use user block for storing Onion VFD information.
Yeah, that's where I thought it might go, but
right. Essentially, I need to talk to John because, frankly speaking, it can go at the end of the file. And somewhere in Superblock, we need to modify just to have a hint that it is Onion VFD, which we did for multi-driver, right? So we do have a header message to do this. Or whatever in Superblock, there are fields, but maybe he didn't want to change file format specification, because you still need somehow to point to that first information about the driver itself, logical size of the pages, and where to find the first index for updated pages, because library does scan the whole history, building the index of all updated pages and serves them from that index, uses that index to serve those modified pages.
Okay.
And according to today's discussion, it's okay to use user block, which is much easier than all this, changes in file format, etc.
Yeah, I definitely think that'd be a nice improvement to the Onion VFD instead of having to have a separate file.
Right, but one of the issues is that file, if you do a lot of changes to the file, it's really bad because we will be using a lot of space. So we need to go back and really store only diffs between the updated pages and not the whole redundant page with modified data.
I have a question regarding Onion. Let's imagine you're developing something, and after 10 revisions, you actually satisfied with the end and only want to store the end. How do I don't know, get a new, fresh version and get rid of all the revisions? Can I just copy everything somehow, or how would it work?
Actually, I don't think it's implemented, but yes, tools and there are APIs to discover the version, and you, for example, may use H5 copy or H5 repack tool to only move to the newest, to have file with the latest or whatever version you're satisfied with. Also, there is now no branching, which will be really important for AI and machine learning applications. Once again, it's not difficult to do. It is just development time. But we can not only store linear history, but also have branching and, for example, have second version or version 2 of your modifications.
Thank you.
Yeah, Elena, I think there's something I would like you to take a look at. There's something called Ice Chunk. It's something being developed on top of SAR, but it does implement chunk level based data versioning. And so I think this is something that you're gonna have to contend with. But this does help that, okay, I'm only changing this part of the array or data set or tensor or image. And so this allows you to refer to a mix of kind of old chunks and new chunks in your data set. And it basically also provides kind of some Git-like features as well. So I think this is something I would like to see in HDF5 as well.
Well, have you worked with Onion VFD?
Not very much, no.
Because it's, I don't know what they're doing there, but really, HDF5 file is divided logically in pages. And for example, right now with chunk modified, and for example, it fits into the page, that page will be stored as a modified page, then the library will know from where to fetch it. And there is nothing to prevent us not to store the whole page, but just diff between previous page that contains the chunk. So I think it may be very efficient. And then, but what you're talking about, compatibility with their solution?
No, I'm just getting the sense they might be a little bit ahead of you because they do have branching and tagging and whatnot. So I think it's something you should take a look at.
Okay. Thank you for pointers. Mm-hmm. Maybe someone has a question about swimmer. VFD swimmer might be a love topic.
No, nothing here.
When I have you here, Zdenek, and like you mentioned that only with the previous or the current production version of Swimmer, only raw data can be updated. Yeah.
Mm-hmm.
What about attributes? Are they updating as well? Attribute values.
A new implementation allows you to update attributes, create new attributes, delete them, to modify all HDF5 file structure. Plus, of course, adding and deleting data.
Mm-hmm. But the old one, is it at least
no,
if the attribute is there, the value is updated or not?
In the old one, you only can update raw data, so elements of the dataset array.
Okay, thanks.
Where are we in terms of like file-based parallelism? I think this is the thing that surprises the most people is that you have two different HDF5 files and maybe you try to modify them from different threads or something, or maybe even two connected processes. People have problems with file locking and whatnot.
That's what I will be talking tomorrow about, going toward multi-threading HDF5. So this is coming feature.
Okay, thank you.
And I'm really interested in working with applications to test our approach because performance this is where we need. So currently we're working on correctness. So multiple threads can enter the library and do whatever they want. For example, each thread opens its own HDF5 file and modifies it and writes to it and so on. So we're working on correctness, and next step will be performance of that feature.
And for the time being, I mean, BLOSC2 already implements multi-threading, right? Reading, at least for reading from disk, right? So you can, if you use BLOSC2 as a filter, then you can read in multi-threading mode as well, right now.
Yeah, but it's still one file, right? You cannot read from multiple files.
Yes, from one file. Yes, it's for reading the small chunks, the small blocks in the same chunk.
Mm-hmm.
Yeah, sorry.
I have a small issue that I brought up briefly in my talk. And this is maybe more for Gerd, which is the checksum. I'm just noticing that it's just getting much harder to find an implementation of lookup 3 in whatever language I'm using. Whereas CRC32C, has processor hardware level support these days, and it's very common in standard libraries. And so, when looking and or trying to examine or even modify HDF5 at the byte level, this becomes a major impediment to trying to understand the file structure. So I'm wondering if there's been any thought about considering allowing alternative checksums or CRC32C specifically.
Jordan, I can answer it.
Maybe go ahead, Elena.
Oh, okay. So did I understand correctly that I believe HDF5 library uses whatever it is, MD5 or whatever is checksums?
It's Bob Jenkins lookup 3.
There is nothing prevents us to use something different on metadata pieces and on raw data. And remember, checksum only can be applied to chunk data sets, not to contiguous and compact is in metadata. So if you use new file format, it will be there. But it's not available now in the library, so it should be interface that allow users to specify like different compression methods, different filters. But I believe someone from, Jordan is online. Jordan, can you elaborate on this, please?
Well, I haven't looked at that particular section of file format specification in a while, but I don't see any particular reason why we couldn't allow for alternative checksums. And as with everything else, it would probably be good to rely on third-party dependencies for doing that instead of trying to do all of that ourselves. So I think, like you said, allowing people to specify their own checksumming method would be definitely a good improvement.
Yeah, but we step into danger like we have with filters, that files will not be readable if users do not have that particular thing on the system, right? And we have discovered, like with filters, what type of checksum is there. So it is, when you have it inside the library and use it, then it's portable. But if not, we're facing the same issues like with filters.
Right, and I would imagine it would at least be a file format extension with some sort of flag telling you that we're not using the default type of checksums, and we have to look for something else.
Right, there is need for modification of file format too. Mhm.
Yeah, I think, Elena, you were mostly referring to kind of like data chunk checksums, but there's also kind of the file metadata checksums, for example, at the end of the super block.
Right, it's metadata too, and library uses the same, I believe.
Right. Because I think there already is a CRC32C implementation in the HDF5 code base. It's just you don't really use it for the metadata. But just trying to kind of parse data structures manually to inspect how does the HDF5 file work. I think I've always found this to be the most difficult part of it, is just making sure I have correct Jenkins 3 implementation or lookup 3 implementation. And I'm getting worried about that because kind of, this is, I think, back in 2000, whatever, when we started developing HDF5, right, it wasn't clear that Jenkins, the lookup 3 or CRC32C was superior, but now in 2025, it's pretty clear that there's an Intel instruction or Intel acceleration on their processors for this. And so I'm wondering if CRC32C would be a better future-proof checksum going forward, even though it might be harder for older HDF5 libraries to read it.
You should add it to wish list for 2.0 release.
Yeah, I am thinking about that.
Yeah.
I think 2.0 would be a great place to maybe.
But remember, it's a wish list, right?
Yeah.
Okay, I think we'll wrap up for the roundtable for today. Thank you for all the participation into the roundtable, and we'll resume tomorrow at 9, right? I think 9. Right, thank you.
Thank you.
Thank you. Bye. Have fun. Bye.